I'm at Stanford University. In the spring quarter of 2025, there was a new class held called CS99, Functional Programming and Theorem Proving in Lane 4, held in the main history corner. It's over here on Mondays and Wednesdays. And if you were to attend this class, you might notice a familiar blue creature teaching this perfect math class. Touhou in the academic world is decently active. There's a couple of papers related to Touhou in a variety of contexts. There's a student-taught course about Touhou at Carnegie Mellon University, and there's a PhD candidate at the University of Utah named Marisa Kirisame, but Touhou sneaked into a regular course is relatively rare. So I decided to head to the San Francisco Bay Area to investigate. And now I think it's time for a transit montage. CS99 seeks to give you an introduction to the fourth version of Lean and how to do functional programming, theorem proving, and metaprogramming in it. And helping you along the way are Cirno and Rumia. So what better way to figure out what they're doing there than by talking to the instructor who put them there in the first place. Hello and welcome to the Touhou Hijack Field Club. My name's Delta Pi and this is
Chrysoberyl. I am the director of NorCal Hackero Factory number 1.
We're here to discuss CS99. How did this course start out and how did you get involved in it?
Okay, so CS99 is a course at Stanford University about Lean, the programming language and proof-resistant Lean. One big thing we're missing right here is any sort of courses about type theory and proof resistance. And I'm pretty well versed in this area, so I decided to launch my own course. And that's how the course came to be.
The course number is 99. Can I assume that this is an obvious reference?
Indeed, it's a reference, but it's not a very obvious one because I initially wanted to take CS9, but that was already taken. So I just got CS99 instead. So far, nobody has commented on the numbers.
What was the first inspiration behind bringing in this perfect math class sort of theming?
So first of all, this perfect math class really fits the theme of this course because the whole idea of a proof resistant is that it can ensure your mathematics have no errors. So it can check your proofs. That's why it's called perfect. And that's the first reason. The second reason is that I actually know some people who have gotten Touhou hijacks, including Tessa Zhang, the author of Aya Prover. And Tessa knows Dr. Marisa Kirisame, who is a PhD student from University of Utah, publishing under the name of Marisa Kirisame. And those are the inspirations of executing this sort of hijack. I don't want to have the hijack being really out of place, so the hijack has to fit the theme of the course. In this case, the theme is mathematics.
How many students ended up taking this course?
So initially we had 20-something students, but only 8 students remained in the end. So initially I promised that if I offer this course the next time, it will have weekly homework and exams. And many students told me that they want to take that version of the course, and so they drop out. But still, we have 8 people who stayed with us to the end. Now, at Stanford, there's a habit of the students that they don't actually physically come to class, which I guess is understandable. Also, I'm a new instructor. This is my first time teaching a course, so maybe my teaching quality is not up to standards. So I would say that having 8 people in the end is okay-ish. It could definitely be better.
I looked at the site earlier and I saw there's some notes about the autumn 2025 edition. So are you going to be teaching that? Or
probably not, because whether I can teach another version of the course is dependent on interest. If many people are interested in the course, I'll teach it. Otherwise, I will not. So the earliest this course could be offered again is probably winter 26.
All right, so any of you at Stanford, that's when you can take this course.
Or you can just directly send an email to me or my PI, Dr. Clark Barrett, asking for this course again. And if enough of you ask about it, it will get delivered again. But on the other hand, all the materials are online, so maybe you can just read through the course notes if you are interested in learning about these.
So did any of the students notice the Touhou theming?
No.
No.
This place is Touhou Desert, which is unfortunate because Berkeley, across the strait, has so many Touhou fans.
In the slides, Rumia and Cirno, however you want to pronounce it, play distinct roles. Rumia gives advice from the computer scientist perspective, like syntax tips. She shows up a lot more often in the functional programming section of the class. Cirno gives advice from the mathematician's perspective, such as mathematics concepts and their implementation in Lean. She shows up more often in the theorem proving section of this class. So why these particular characters?
So
Cirno is an obvious choice, right? But what about Rumia?
So Rumia is associated with the number 10. 10 is 1 and 0. You get it?
Binary.
That's why also the natural pairing of the two characters makes it a very obvious choice to have Rumia explain functional programming behind.
You mentioned wanting to sort of not make it
Very out of place.
very out of place, yes. So how useful was showing Rumia and Cirno in explaining these concepts to students?
I think the red and blue box are an integral part of the course and they should not be deleted because they contain important commentaries about why a certain thing is structured in a particular way, or syntax tips that would otherwise interrupt the flow of the course. So for this reason, I think these boxes are very helpful. And the primary role of Rumia and Cirno is to support these boxes.
So that's the hijack. But how do we get here? It's a surprisingly Touhou-filled story. This course is on Lean, it's a theorem prover. Your research work is on machine-assisted theorem proving. There we go, I can actually say it. So what is MATP and why should we care about it?
So right now, the machine learning models like ChatGPT and stuff, there's a problem with them is that their outputs are hard to check. In many cases, their output contains errors or hallucinations. With Lean, a proof assistant, we can rigorously check the logic of any statement that can be formulated in Lean. So this is why this line of research is important, and you see that more and more companies are joining this race to develop a theorem-proving agent that can advance the frontier of mathematics. And that's basically a machine-assisted theorem proving in a nutshell. You're trying to find proofs using machine learning in Lean.
So you currently got a series titled Information Sign explaining MATP to the general audience. What was the inspiration behind this concept?
So the whole reason information sign came into being is because in our lab, every single month we're supposed to write an article for the lab blog. And last year there was a noticeable shortage of such blog posts. So I volunteered to fill up the gap by writing a series of expositions about SMT solvers. And that's basically the source of this information science thing. And I don't want to frame SMT solvers as this sort of really esoteric algorithm that nobody cares about, but rather that it's a very intuitive thing that just exists. And we execute calculations like an SMT solver every single day without us noticing it. That's the reason for the series.
In that sense, what role does MATP and SMT solvers, what role do they play in people's everyday lives?
So I would say that SMT solvers are a tool for solving, say, logical constraints. So for example, you could say that in the information science series, you could find that there are planning problems, which can be very nicely formulated in the language of SMT. For example, you can say that I want to find a solution which satisfies all of these logical constraints. That's fundamentally an SMT problem. So for example, if you want to arrange a picnic with your friends and each friend can only bring certain items, and that will be a logical constraint. And there's another class of logical constraints which are spatial. So maybe you want to find you're driving a car and then you want to find the shortest or fastest way to get from point A to point B, and that could be formulated into an SMT problem.
So you're part of the Centaur group, right?
Yes.
Yes. Which is focused on sort of getting these technologies out to industry. How does that process tend to work?
So we already have connections with Amazon and other industry players, and they use our SMT solvers to verify security protocols. And there are also applications about verifying, say, smart contracts and verifying dynamical systems. Like for example, you can say that there's an airplane and it never falls out of the sky or something like that. That could be formulated as a constraint.
What are your current projects in METP?
So I have a couple projects. The first one is the first one is to create a system that can think like us in terms of mathematics. So I wrote a bit more about this on my research page, if you're interested. The main observation that we have in this project is that most of mathematics is written down in a different order than they were first conceived. And therefore, if you want to reason in terms of mathematics, we want to trace the steps of the ideation of the proof instead of tracing the steps of the published proof. And that's called divergence between the presentation and the search field. And that's also outlined in my paper. And one of my projects is to leverage this difference to produce constraints on variables in mathematics. That's one project. The other project is to use SMT solvers to model natural language, which will provide a path towards symbolic artificial intelligence.
So nowadays, everybody is a lot more exposed to sort of machine learning, language learning models, and artificial intelligence. It's the big craze, right? So what differentiates this technology that you use from, say, something like ChatGPT that is more common in the market nowadays?
Our system is entirely white box and also symbolic, which means that if you don't trust its work, you can go ahead and verify it. Whereas nobody knows how ChatGPT works internally. Then another thing is that we don't use language transformers, which as the name GPT suggests, is actually extremely expensive to train, and we don't have that much money. And I think having a model that's smaller, that can be trained by basically everybody, also provides more to the society than having a model that only OpenAI knows how to train.
CS99 isn't the only instance of Touhou in the theorem proving world. The observant eye might notice that one of the theorem provers mentioned on the slides is named Aya, and yes, this is a Touhou hijack. I've previously written a thread about the Aya theorem proof assistant headed by Tessa Zhang at the Carnegie Mellon University. Theorem provers often have names themed around birds. The team had gone through a few Touhou related names before settling on Aya, which also conveniently happens to be the Hebrew word for bird. They've gone all out on the Aya theming. It's everywhere on this project. So just how prevalent is Touhou in the theorem proving world? It seems like 2 instances of Touhou is kind of a lot.
Okay, I generally find that when you say theorem proving, for us it usually means type theory and also programming languages research. What I found out to be really puzzling is that there are actually a lot of Touhou fans in this field. I don't know exactly why, but we have a programming language Discord, and many people on that Discord, at least they have heard about Touhou. We have a collaborative project for a music DSL in Leni that's called Chrysoberyl, and that's another Touhou reference, and all of these people just know about it. For exactly what reason, I don't know, but it's an interesting observation in comparison to the machine learning people. And I would say that very few machine learning people actually care about Touhou.
Well, I have to ask, when and how did you get into Touhou?
Okay, I got into Touhou about 15 years ago, and it was a really weird journey to get into Touhou, because when I initially discovered a website called Nico, and it's a Japanese video sharing website. And then on Nico, there's this, I would say, a form of art. It's called Geniki Vocaloid, manual Vocaloid, which means that you take videos and you cut out individual words from them, and you remix those words into songs. And that's what led to stuff like Gachimushi, and then there's Air Moto. And I was very interested in Air Moto because it's very fast and stimulating. So when on Nico, there are 3 works which are collectively known as the Gosanke, which are Touhou, Vocaloid, and Idolmaster. When Touhou is remixed with Air Moto, which is like basically propaganda videos from a religious organization called Sohoka Gakkai. This is called Touhou Zuhasibun. Touhou Zuhasibun is actually a reference to the Buddhist origins of Sohoka Gakkai. And it's very stimulating. It's like, back then there aren't that many things in my life that were very stimulating. So I just watched this stuff, and that is how I got into Touhou. And I think when every single time I tell this to other people, they think it's absolutely insane that somebody can get into Touhou this way, and I generally agree.
So you have a blog post on this as well, which you should all check out. I guess it'd be linked somewhere in there. I don't know where the card is.
It's on my website. You can easily find it from this page.
You also got into computer science through the same source as well, right?
Indeed.
So how was that journey?
So I wanted to make my own Touhou Aeromoto music, and I tried to write an automatic algorithm to do it. But it was actually very, very difficult. I didn't know that. It's very hard to create an algorithm that automatically generates or remixes voice. So after attempts and reading a bunch of books about signal processing, and that basically got me into computer science and mathematics as well. So I would say that Touhou has changed my life entirely, and without Touhou, I would not be here. And I would probably in a completely different field, maybe in the animations or the arts.
So after getting into this field through Touhou, how else has Touhou impacted you in your professional career?
Well, I would say that one of the biggest impacts is that there were numerous attempts to basically lure me out of academia to join industry for startups. But other than the legitimate reason, which is that I don't really believe in those startups, the other reason is that if I were to join industry, then I wouldn't have time to do Touhou cosplay, and I wouldn't have access to the fantastic array of machinery that we have here in Stanford, and that's why I did not do that. And I would say that Touhou has played a huge role in this as well. And I would say that the biggest inspiration from Touhou is that the way we play Touhou games is actually an execution of a very interesting algorithm, and that algorithm has inspired many innovations in my projects.
I guess we'll move on to talk about Touhou. Leni has a lot of interest in the Touhou world, but she's most well known for cosplay. She's the head of the cosplay division at the Stanford Anime Club and works on prop making under the name NorCal Hakuro Factory No. 1 quite successfully, as she won a judges award in the Touhou Fest 2025 cosplay competition with her Machine Gun Kaneko cosplay. So how did you get into cosplay?
So I got into cosplay because I like Touhou, and then I learned that there's Touhou Fest, and then I thought maybe I should go to Touhou Fest. But if I should go to Touhou Fest, I want to do cosplay, and that's basically the reason why I got into cosplay. Also, for me, making my cosplay is a engineering process, and I really enjoy the process. This process of engineering and making a thing that I design and personally design, and I think that's really rewarding for me.
In her blog post, Lowering the Barrier of Entry of Cosplaying, Leni describes 4 areas of cosplay and frames the barrier of entry as the difficulty for people to cross all barriers. So you describe a variety of skills related to cosplaying, but from what I read on your blog, you seem pretty involved in every step in the way. At various points, you described your experiences in film grade post-processing, cosplay design, prop engineering. How did you develop this wide skill set, and what advice would you give to cosplayers that want to start out in developing this broad range of skills?
So I actually developed this skill set from my background, because in the past I was an art student, and when I was an art student, we had to make animations and schematics, and these animations are not practical at all to make in the real world. But it starts as it's an inspiration, and when I wanted to learn how to make a certain kind of cosplay, I would find other people's work, and I would try to learn from other people's work, and that's how I gradually learned about this. And each of the cosplay making skill is actually based on some other skill that people use in the normal world. So for example, sewing, for example, like CAD or post-processing. So I found books for these subjects, and I read the books, and that's mostly how I learned about sewing. And for CAD, I learned it by looking at examples. CAD is actually very easy to learn. You know, if you have a sense of the 3D space, it's actually very easy to pick up.
Leni has a full article on the award-winning Ambashira design, which you can check out here. But we have a, I guess this is a rebuilt version, right?
This is not a rebuilt version. This is actually the part from the Ambashira that I used that I showed at Touhou Fest and Anime NYC. So this is an example of cosplay engineering because we have to conform to constraints that don't exist in the real world. So, for example, this Ambashira, like, you can technically classify as a weapon, and many conventions forbid metal parts in weapon-like props. So for this reason, I can't make this disc out of metal. By the way, this disc is where this disc allows basically the gun barrels to rotate. And there's a motor behind the disc that drives the barrels. So the innovation on this is that this is made entirely of plastic, except for these little bolts, which will not trigger the metal detector. And if you want to make a bearing mechanism out of plastic, and that is very different from making a mechanism out of metal, because plastic is much weaker and more flexible than metal. So for this reason, I don't think people can see the inside, but instead of having metallic bearing balls, we have bearing spindles, which are like the two flanged wheels of a train riding on two sets of tracks. So if you take a look at this thing, you'll see that there's an inner disc, there's a track, there's the bearing spindles which are mounted on this ring, and then there's the outer disc. The inner and outer discs are the tracks, and this ring holds the wheels of the train. So when I rotate the inner disc, you'll see that the ring rotates at half speed, and that shows you that there's contact between the bearing spindles and the inner and outer discs. So you can see that each of those spindles rotate on the tracks, and that provides a self-righting mechanism. So if the spindle drifts out of place, the tracks will push the spindle back into place. So that's an engineering decision that we have to make to ensure the spindles are, to ensure that the thing doesn't tear itself apart. So this is what happens if you rotate from the top. So the reason we have this spindle is because our engineering constraint is that we can't have a very powerful motor. And this thing can rotate with just 30 watts of power, which is another engineering constraint that we have to face. So this is why I say cosplay prop engineering is a very specific kind of engineering, and it has its own unique set of constraints. So that's the story about this bearing disc mechanism. You can find the schematics about this thing on my website.
As you describe in your article, the prop design of the Ambashira is entirely parametric. Are there any issues presented by this kind of design, and how did you choose the final size of the actual prop?
So first of all, this whole thing exists because somebody drew Kanako with a machine gun, and I thought I could make this stuff, and then I just made it. So initially the dimensions were taken from that picture. I put my height into the picture, and then and I converted the ratio between the height and the length of the barrel into the length of the barrel for this prop. It turns out that doesn't actually work because that made for an extremely large Ambashira. So then I went to the lab and I checked out the dimensions of our laser cutter, and the maximum dimension that we can cut efficiently is 12 inches. So that's about 300 millimeters. For this reason, the side length of the Ambashira is 150 millimeters on the front, and that's limited by the size of the machine. So this is why the design is parametric. Initially, I put, I think, 170 or 180 as the side length, and it turns out it doesn't work. So we can just modify the parameter, and it would generate another Ambashira that's a little bit smaller. That's the benefit of parametric design. And because, as cosplay prop makers, we don't have access to industrial machines, and we have to make use of what we have. For this reason, we need to change the design based on what's available to us. That's the main reason why I use a parametric design. And if you want to make an Ambashira, you can take my design, you can just change a couple of numbers and you can get a smaller or bigger one, and that's not a problem.
And you can find that design on
my website, again, basically in the blog post.
Mhm.
And the entire design is written in Python, about 2,500 lines of Python, complete with its own unit testing to ensure that the thing does not intersect itself. So the main issue in the design process is that if you do a parametric design, so I use cat query, which is a CAD library for Python. You can't really just select something and drag it around. That's not a permitted operation because everything has to be consistent with each other. So for this reason, I had the first prototype in Blender, and then after I decided on the looks of the thing, I would design it in cat query. So this is a much more circuitous process compared to if you just build the whole thing out in Blender or like maybe Autodesk Fusion, which I have never used. Also, the cat query thing it doesn't have many features that you would find on animation software because it doesn't support animation. And therefore, it's kind of difficult to simulate what would happen when the gun barrel rotates.
How do you balance looks, mechanics, and durability when designing a prop like the Ambashira or any other prop?
So I would say the Ambashira is a special case because the surface is supposed to be made of wood, and wood is strong enough and it's light enough, and it looks like wood. So if you make the barrel out of wood, it will look like wood and it will have the requisite strength. However, if you want to make some other cosplay props, like for example, maybe a mechanical wing, that's when you really need to sacrifice material in exchange for functionality or something like that. So I would say that Ambashira is a special case, but even then, this prop is way too heavy to be carried around. And one thing I did not engineer into the prop was a pair of wheels. And that caused a ton of problem when I went to New York.
When going from the computer design of the prop to actually building out the prop, what are some changes that you had to make?
So I had to make a couple of changes. So first of all, this bearing disc design was not the initial design. Initially, I just tried to use plastic bearing balls, which caused a whole bunch of problems because the plastic surface, the acrylic surface of the bearing disc are too flexible and the bearing balls would escape from the tracks. And that's what prompted this design with the bearing spindles. So that was the first change. The second change was that each ring on the Ambashira is pieced together from 6 little ring components. And I had to do a couple iterations before I settled on design. Because this ring component has to do triple duty. It has to look like metal. It has to structurally connect the 2 sections of the Ambashira together. And internally, it has to support the machinery on the inside. So I had to do some iterations on that, and it cost me a couple of dollars to print out the stuff.
Your most recent cosplay is your newest one, which you have on right now. So what challenges did you encounter while designing it?
Biggest challenge is the wing. I'll just be honest, the wing is really, really hard to make. And it called for exotic materials. So hopefully I'll get a wing ready by next year. But on the other hand, making this is actually pretty easy. This is this was made from, the black part is made from one piece of clothing, one piece of fabric. And it turns out that this is, the hardest part to make was this, the collar with the ruffle. Because it requires the needle to punch through 7 layers of fabric at once, and that was really hard. But I would say that clothes is relatively easy to make. And then there's this thing. And one of the engineering requirements for cosplay is that it's able to be decomposed, detached into multiple parts, and transported on an airplane. So this thing detaches into multiple segments. And the way this works, I'm going to show it to the screen, is that this is a bayonet joint. So it means that the two ends slide into each other, and then it just turns and it locks into place. Now this bayonet joint is much easier to print than basically helical screws, because the helical screws will warp during printing, and that would destroy the structural integrity of the system. So that's the thing about this fork.
So what do you use to actually build out your cosplays in real life? So what kind of printers do you use and whatnot?
So the I use the bamboo printer that we have at at our institution. So there's a lab that has a bunch of printers, and then these parts are ready-made acrylic tubes. You can just buy a couple of tubes online. It's pretty cheap. And then each of the bayonet joint is also printed from the same bamboo printers. So this thing is basically all printed. And then for my other cosplay, especially for the Ambashira, I really like to use a laser cutter because it's really accurate and it's really fast. I don't need to iterate. If I want to iterate, I can just use the laser cutter. And the material that you can cut are really durable. Like, for example, 1/8 thick acrylic or wood or leather. And it's much easier to make something on the laser cutter than on the 3D printer. The last machine I use sometimes is the lathe. So when I made the Oku cannon, each of the control rod was machined on a lathe, and the lathe is also a pretty fun thing to use. It's very simple. Like subtractive manufacturing is always easier than the machining is always easier than 3D printing.
You mentioned this a bit earlier, but in your experience in cosplaying in the Bay Area, how recognizable are Touhou cosplays?
I think they show up sometimes. It's not incredibly common. Usually if you go to, say, Phantom A, there are, I would say, 10 Touhou cosplayers. I think that's pretty good. Like, having a niche Touhou is pretty good. And one of the most fun things about going to anime convention is to try to find out who are the Touhou fans. I would probably just walk around with a Touhou cosplay, and some people would recognize it. There's actually a Bay Area Touhou server. It's called Bayho, and it's a Discord server, and we have about 150 people in the server. And I would say that Bay Area is actually a hot spot for Touhou fans, relative to other parts of the country.
Looking back at the role that Touhou has played in your life, which has played a pretty big role, what advice would you give to people who want to sort of combine their career with their passions?
So I think it's highly career dependent, but I would say that Touhou has so many related things. You can probably find a way to have a little bit of Touhou in your life. For example, if you play an instrument, you can play Touhou music, or you can know how to make stuff. You can make Touhou themed things, and if you know how to make clothing, you can make Touhou inspired clothing. These are all possible. But it's highly dependent on what kind of skills you have.
Yeah, there's so many things that a Touhou fan work can be, right?
Yeah.
So it can take the form of, prop engineering. It can take the form of cosplay. It can take the form of even, teaching a class, right?
Yeah.
And that's what I've seen from Touhou Hijacks, is all the creative ways people find to sneak Touhou in wherever and whenever. And so a few more software engineers march out into industry, equipped with the tools they need for theorem proving learned from Cirno's perfect math class. As I mentioned a few times, Chrysoberyl has a blog that you can check out if you want to continue following her work alongside her social media accounts, which will appear here and also in the description. Thank you to Tessa Zhang for submitting this hijack, Leni Aniva for the interview, and you all for watching. And I'll see you next time on the Touhou Hijack Field Club.